We are in Unit 8, and this is our first section. Today we are going to be looking at derivatives of inverse trig functions. So I could just give you the formula for all of these, but I'd like to show you where these derivatives come from. So let's begin by let's consider y is equal to arctan of x. And we know that this also means tangent inverse of x, right? So if y is equal to arctan of x, that means if we take the tangent of both sides, that means that tangent of y is equal to x, right? Before we do anything else, let's go off to the side and let's describe this situation in a triangle. Okay, in a triangle, y, in a right triangle, y would be the angle, right? So I'm going to call this little angle y. Tangent of y would be x over 1. So tangent is opposite over adjacent, so x over 1 would be right there. And then we can use the Pythagorean theorem to get the hypotenuse. The hypotenuse would be the square root of x squared plus 1. So this triangle describes this situation, and it describes this situation, okay? Both of them. All right, let's keep on going. Now that we have tangent of y is equal to x, let's take the derivative of each side with respect to x. So we're going to take the derivative of each side with respect to x. And if we do that, the derivative of tangent y with respect to x would be secant squared y dy dx. The derivative of x with respect to x is 1. And now we can solve this for dy dx, and we get dy dx is equal to 1 divided by secant squared y, right? 1 divided by secant squared y, which is the same thing as cosine squared y, right? Okay? So, we would like to get this in terms of x. And to get this in terms of x, I'm going to go and take a look at my triangle. Okay? If I go and take a look at the triangle, it is going to be easier for me, well, this will be good. If I just take a look at my triangle to get it in terms of x, cosine squared of y is the same thing as cosine y squared, right? So cosine of y would be adjacent over hypotenuse, 1 over square root x squared plus 1. And then we square it because cosine is squared. So dy dx is equal to 1 over x squared plus 1. Therefore, the derivative with respect to x of arctan x is 1 over x squared plus 1. There's our first formula. Okay? All right, so the derivative, this is an interesting situation because the derivative of this inverse trig function has no trig functions in it. It's just algebraic. Okay? So this is a transcendental function, and the derivative of this transcendental function is not transcendental at all, it's just algebraic. It's interesting. Okay, let's do the same thing. Instead of doing it for arctan, let's come and do it for arcsine. So let's consider y is equal to arcsine of x, which is the same thing as sine inverse of x, right? So if y is equal to arcsine of x, then sine of y is equal to x. We take sine of both sides. Let's go off to the side. and draw a triangle representing that situation. So sine, we use a right triangle. Y is the angle. Now sine is opposite over hypotenuse. So this time the x is the opposite. The 1 will be the hypotenuse because this is x over 1, right? Therefore, by Pythagorean theorem, this side will be the square root of 1 minus x squared. Okay? Let's come back to our equation and let's take the derivative of both sides with respect to x. And if we do that, the derivative with respect to x of sine of y is cosine of y times dy dx. The derivative of x with respect to x is just 1. So dy dx is equal to 1 divided by cosine y, which is the same thing as secant y. But again, I'd like to get this in terms of x. So what is secant y? Well, secant y is hypotenuse over adjacent. So 1 divided by square root 1 minus x squared. Therefore, the derivative with respect to x of arc sine of x is equal to 1 over square root 1 minus x squared. And there's our second formula. So this is a little bit interesting too. Okay, let's do the one for arc secant x. So now let's consider y equals arc secant x. Well, if y is arc secant x, then that means that secant of y is equal to x. Let's come off the side and draw our triangle representation of that situation. Okay? If this is angle y, secant of y is x over 1. Secant is hypotenuse over adjacent. So this is x over 1. And that makes the opposite side the square root of x squared minus 1, Pythagorean theorem. Let's come back to our equation and take the derivative of both sides with respect to x. The derivative with respect to x of secant of y will be secant of y tangent y times dy dx. Derivative of x with respect to x is just 1. So dy dx will be 1 divided by secant y tangent y. Okay. We could change this if we wanted to. In class, I'd probably ask you if you wanted to change that. I think I'm just going to leave it. Let's put this in terms of x's. Okay. I was thinking I could change this and maybe put cosine up on top, or things like that. But I think I'm just going to leave it. Let's see what happens here. So we'll have 1 divided by. Okay, what is secant y? Secant y is x over 1. Right? So x. What is tangent y? Tangent y is opposite over adjacent, so square root x squared minus 1. So this means the derivative with respect to x of arc secant x is 1 divided by x square root x squared minus 1. Okay, now I need to make a little caveat here. In this expression, x can be negative, okay? The derivative here is always going to be positive, okay? It's always going to be positive. And that comes from restricting the domain and stuff, okay? So that's going to always be positive. All right? So we need those absolute values here in this formula. Okay? It's this for this similar reason in that we, well, no, it needs to be positive because of that domain restriction. It's always going to be positive. Okay, so therefore, we have, let's put it all together. We have the derivative with respect to x of arctan of x, and that is 1 over x squared plus 1. We have the derivative with respect to x of arc sine x, and that is 1 over square root 1 minus x squared. We have the derivative with respect to x of arc secant x, and that is 1 over absolute value x square root x squared minus 1. Okay, so we have those three, and now let's use our knowledge of the derivative of trig functions to come off to the side here for each of these, and let's find the derivative of arc cotangent x, arc cosine x, and the derivative of arc cosecant x. So we're finding the derivatives of all the cos to these, all right? Okay. So if the derivative of arc tan x is positive 1 over x squared plus 1, then the derivative of arc cotangent will be the negative of the same thing. Okay? The derivative of arc cosine x will be the negative of the derivative of arc sine x. So negative that. And the derivative of arc cosecant will be the negative of the derivative of arc secant. So here are these derivatives that I now need you to know. Okay, I need you to know them without having to derive them every time you go to use them, right? So let's put those in your memory banks. All right, let's take a look at some examples. In example 1, we're going to be finding the derivative of each of these. So let's say that we have f of x is equal to arc sine of x squared. Okay. Well, the first thing to know is that this is a little chain rule. We'll just take the arc sine of u and then multiply by the derivative of that inside, right? So f prime will be, first do the derivative of arc sine, right? So the derivative of arc sine is 1 over square root 1 minus x squared, but our argument is x squared, so it'll be x squared squared. X squared squared is x to the 4th. And then you multiply by the derivative of the inside, 2x. So this becomes 2x divided by the square root 1 minus x to the 4th. Okay? Number 2. Let's say g of x is equal to arc secant of 2x. All right, then g prime of x will be, first find the derivative of arc secant of u and then multiply by the derivative of u. Chain rule. 1 over absolute value u, 2x, square root u squared, so 4x squared minus 1, and then you're going to multiply by the derivative of 2x, which is 2. Okay, this would be a safe stop spot. So question, do these 2's cancel? Can you take a 2 out of an absolute value bar? Yes, you can, because the absolute value of 2x is the absolute value of 2 times the absolute value of x. That's what it means. And the absolute value of 2 is just 2. So this is 1 over absolute value x square root 4x squared minus 1. Okay? It would be good if you remembered this little example for tomorrow. Number 3. Let's say that h of x is equal to, I'm going to write it a different way because sometimes you see it written a different way. Instead of arctan, you will see both arctan and tan inverse. You'll see both arcsecant and secant inverse. You'll see all of those. So get used to seeing those 2 different ways to represent an inverse trig function. Okay, let's find the derivative. So for the derivative, first do arctan of u, so that would be 1 over u squared. What's the square of the square root of x? Just x. Plus 1 times the derivative of the square root of x. What's the derivative of the square root of x? That would be 1/2 x to the negative 1/2, right? So that would be, I'm going to just put that over here, 1/2 x to the negative 1/2. This would be a safe stop spot, but not a multiple choice answer. As a multiple choice answer, what would they do? They would probably put the 2 and the square root of x and then times x plus 1. That's what they would do for a multiple choice answer. Okay? Number 4. What if we have f of t is equal to t squared arctan of 5t? What is f prime of t? Well, this is a product rule because we have a product of 2 functions. So start with your t squared, the derivative is 2t. Leave the other function alone. Plus, now we're going to leave the t squared alone and write the derivative of arctan of 5t. The derivative of arctan of 5t is 1 over 5t squared, so 25t squared, plus 1 times the derivative of 5t. So times 5, so I'm going to put that 5 up on top. And that's it. Probably close enough to a multiple choice answer for you to pick out a multiple choice answer. Okay, example 5. Let's say that we have y is equal to 2x arc cosine x minus 2 square root 1 minus x squared. The derivative will be, okay, this we need to use the product rule for. So 2 arc cosine x plus 2x times the derivative of arc cosine x. Well, the derivative of arc cosine x is negative 1 over square root 1 minus x squared. After you do a few of these, you will have those memorized without trying much, if you do them. So you're going to need to practice if you want to have those memorized. Okay? Okay, and then we have we need this derivative. So I'm thinking of this as 1 minus x squared to the 1/2, right? So 1/2 times negative 2 is negative 1. And then we would have 1 minus x squared to the negative 1/2 power. And then we need the derivative of the inside, which is negative 2x. Okay? So that would be a safe stop spot, but not a multiple choice answer. So let's look at what we have here. We have 2 arc cosine x minus 2x over square root 1 minus x squared plus 2x over square root 1 minus x squared. And what happens? These two zero out and we just get 2 arc cosine x. So the derivative of this is 2 arc cosine x. That's interesting because that means the antiderivative of arc cosine x would look something like this. We will get there, but not this unit. We save that for unit 9, I believe. Yep, our next unit. Okay, number 6. Let's write the equation of the line tangent to the graph of y equals 2 arc secant 3x at the point 2/3 2 pi over 3. Okay? Alright, so equation of a line, we need a point and a slope. We're given the point. There's the point. Now let's get the slope. Well, the slope will be y prime at that point, right? So y prime is going to equal 2 times the derivative of arc secant of 3x. The derivative of arc secant of 3x is 1 over the absolute value of 3x times the square root of 3x squared minus 1 times the derivative of 3x, which is 3. Okay, now we're going to need to put in 2/3 for x, right? We're putting in 2/3 for x. So this will be 6 over, and then if I put 2/3 in for this x, I'm going to get just 2 down there, square root, okay, 2/3 in for this x, so that'll be 4/9 times 9 will be 4, so that's 4, and 4 minus 1 is 3, so this will be the square root of 3. So this is 3 over square root of 3, right? Which is just square root of 3. If you rationalize that, you just get a square root of 3. You can totally leave it 3 over square root of 3 if you want to. All right. So we know a point and we know the slope, so we can write the equation of the line. So the equation of the line would be y minus the y value is equal to the slope times x minus the x value. Okay. Example 7, last example. Write the equation of the line tangent to this curve. Arctan of xy is equal to arc sine of x plus y at the point 0, 0. Okay. Well, first up we need point. Well, we're given the point. And it's a convenient point, it looks like. So that's awfully nice. So it's a convenient point. We have the point though, so let's just go get the slope. We need the slope is dy dx, right? So here's our curve, and we need dy dx. So we're going to need to use implicit differentiation here. So I'm going to write my equation, and we are taking the derivative of both sides. with respect to x. Why with respect to x? Because we need dy dx. We need dx on the bottom. Okay? All right. The derivative with respect to x here will be 1 over xy squared plus 1 times the derivative of xy with respect to x. So now we need to come and use the product rule. So the derivative of x is 1 times y plus, we're leaving x alone, the derivative of y with respect to x is dy dx. Okay? Any questions on that little piece? Okay? And that's going to equal, now we need the derivative of this side. So that's going to be 1 over square root 1 minus this squared, right? So x plus y squared times the derivative of x plus y. What's the derivative of x plus y? 1 plus dy dx. Okay? We took the derivative. At any time after we take the derivative, we can plug in our point. And I think it's a fine time to plug in our point now. Do you? I would like to plug in my point now rather than do any work on this. So I'm going to say at 0, 0, I'm communicating what I'm doing. At 0, 0, this is now 0 and this is just a 1. So we'll have 1 plus 0 dy dx. So this whole side is just 0. That's nice. Now let's come over here. X plus y is 0. Square root of 1 is 1. So this is 1 times 1 plus dy dx. So what is dy dx? Just negative 1. Okay? So the equation of the line is y minus the y value is equal to the slope times x minus the x value. So it's just y is equal to negative x. Alrighty. So derivatives of the inverse trig functions and how to use them. Tomorrow we will do integrals yielding inverse trig functions. But for now, you need to go and practice these. Because you can't do antiderivatives without knowing the derivatives well.